Hello friends, welcome to my YouTube channel AI Geek. In this video, we are going to discuss about can artificial intelligence be applied in stock market. It's a very interesting topic. If you are really wondering, can we apply artificial intelligence technique to predict stock prices to make profit out of it, whether it is possible or not, the answer is yes. Yes, we can do it. But the crux lies in building a robust algorithm which understands the data and then makes a informed prediction which can help you make money. We have been doing this since last 2 years, and if you want to explore more, you can refer to our website prudentcap.in. I have mentioned this website in my description box. In this video, we will discuss one of the machine learning techniques, k-means clustering, and try to see how this can be utilized in classifying or identifying similar stocks. This is one small application of artificial intelligence in the stock market. Of course, there is much more to it, but to start with, we'll try to see how this technique works. So before we start, let's try to understand what exactly is clustering. Well, clustering is a part of unsupervised learning. I'm sure you must have seen my previous video, supervised and unsupervised learning, or you very well understand what is supervised and unsupervised learning. So clustering is a part of unsupervised learning where we cluster the data. We split the data into small clusters, and each cluster will have similar type of data. Like you see in this chart, we have three clusters: this green, this blue, and this pink. So these data points in the green are similar. This blue has data points which are similar, and this pink one also has similar data sets. So it is clustering them into three clusters. So what essentially clustering does, it splits your data into small clusters where each cluster will have similar type of data. So this is what exactly we do in clustering. Now the question is how we do it. Well, the answer is that if you have numeric data, if you have the data which has numeric values, you can very well apply this technique called k-means clustering. We'll try to understand what k-means clustering is and how it works. Let's see a data here. This is an data of an automobile. So this is the wheelbase, this is the length, this is the width, height, and curb weight, and these are all the data. Now clustering, using this k-means clustering, we have to split this data into various clusters where each cluster will have similar type of data, means similar type of automobiles, a specification clubbed together. So how to do it? Let's try to, you can see here there are 5 features here, means 5 columns, and each have different data sets, and our challenge is to split this data into small clusters, with each cluster having similar type of data. So to start with, what we will do, we will just park these 4 columns aside and just focus on only one column. This is wheelbase. Let's assume we had only this column available and these 4 columns were not provided, and then we are asked to do it. Please split the data into various clusters where each cluster will have similar type of data. So what we will do, we'll consider only the first column here, and let's see how this works. Now we have taken only the first column. You see this data 88, 88.6, sorry, 94.5, and all these data are arranged here in a sequential manner, and these are plotted. Now if you are asked to cluster this data, how will we do it? Well, I'm sure you don't even need any clustering technique. You can, with this kind of data, you can just by visual inspection, you can cluster them. You can tell them this is one cluster, this is another, this is the third one, and this is the fourth one. If you are asked to bifurcate this into various clusters, This is what you will do. You don't need any mathematical technique or algorithm or anything like that to do this. Just by visual inspection, you can do that. It's a pretty simple case. But real life example will not be that simple. It will have multiple columns and then you will have to do it the same thing. Now let's make this problem a bit complex. Instead of taking this only first column, now we are taking two columns. One is the wheelbase, this one, and second what we are taking is grab weight. And let's see what happens. Now we have taken the grab weight and the wheelbase and we have plotted. Now the data is two-dimensional, and once again we are asked to do clustering. Now again through visual inspection you can see that still this is not very complex. You can still cluster them into four clusters like this: 1, 2, 3, and maybe this will be the fourth one. You can still do that. But here what we will do, instead of assuming that this is a very simple data, let's try to formulate a method which we can apply whether the data looks very much classified on its own to a bit complex data set. We will try to formulate a method which can be applied everywhere. So let's try to do this. So let's first remove all this and then we'll try to okay. Now the first thing in k-means clustering is the value of k. K represents the value number of clusters. Let's assume. So now the question will come, how will derive at the value of k? How many number of clusters will be there? That's a very good question. But to answer this question, we will first formulate a method and then try to answer this question. As of now, let's assume some value of k. Maybe we are given a value of k as 3. So we have to classify this, split this data into 3 clusters. Okay. So as a first step, what we do, we identify 3 points, 3 clusters, or 3 points, which are called centroids. Maybe the first point is this. I'm putting a small cross here. The second point is this, and maybe the third point is this. Okay, these are the 3 clusters, and these are the centroids, central points of this. Just we have taken 3 points, randomly selected in this data set. We will take each point one by one. For example, this point, and we will calculate the radial distance of this point from this center. So this is the radial distance. Okay. Now the same points radial distance from this center, and the same points radial distance from this center. How to calculate the radial distance? You all know, using the Euclid theorem. This is the x-axis value, and this is the y-axis value. So this is x, and if this is y, the value will be x square plus y square is equal to z square. That is the distance. So the root of this will be the radial distance. Okay. So applying this method, we take each point one by one and calculate its distance from the 3 randomly selected centroids. Now we have taken value as 3 because we are starting with a value of k as 3. Just randomly we are starting with value of 3. Now the nearest distance is what? Is which one? This centroid is at nearest distance from this point. So let's call this point as x1. This point we call it as x2, and this we call it as x3. So this will belong to the centroid x1. Similarly, we apply this logic to this point. We get with the radial distance from this centroid, and from this centroid. Now again the nearest distance is from this, so this will also belong to x1. Likewise, this might belong to x2. This might belong to, sorry, this would also belong to x1. This would belong to x2. This would also belong to x2. this would also belong to x2 because x2 point is the nearest from these three data points. Similarly, all these three will belong to x3 because x3 is at nearest distance. So this is applicable to all three. Okay, so now you have a fair idea how to do this. So we are essentially now having three clusters, and we have all the data points split or bifurcated into these three clusters. Okay, so these three are into one cluster, these three are into another cluster, and these three are into the third cluster. Now what is the second step? As a second step, what we do, we start changing the location of x1 and to see how this sum of the squares of this distance can be reduced to the minimum possible value. So we start changing the location of x1. I think it will optimize at some point near here. If we move this x1 to here, this will be at the least distance from x1 and x2. Similarly, we start changing the location of x2, and within that cluster, within the data set which are a part of its cluster, will recalculate its distance from x2, x3, sorry, this x2 data sets, and this is also x2. Sorry, this is also x2. So all from x2 data set, and then see the sum of the squares of distance. The value should be minimum. Similarly, we keep changing the distance of location of x3 and make sure that the clusters in the data points included in this cluster, the sum of the squares of its distance of the data points from x3 should be minimum. So essentially this is what we are trying to achieve. Let's try to understand. This is these three were part of one cluster, this was a part of another cluster, this was a part of third cluster. Okay, so we are central point of all these clusters we are changing. So this is let's take the first cluster, that is j is equal to 1, and all these three data points, that is x1, x2, x3, and see the centroid of this j. So the square of distance should be minimum. Similarly, we take the second cluster. Now the sum of the squares of distance from the centroid should be minimum. So Cj needs to be changed in such a way that the sum of all these three clusters, the sum of the squares of distance for all the three clusters should be minimum. Once that is achieved, then we get the exact central points, centroids, and we also get the right clusters. So this is how the whole clustering works. So now you must have understood must have developed a fair understanding how this clustering takes place. Now coming to the original question, how we determine the value of k, whether it should be 1, it should be 2, it should be 3 or 4. Now to answer this question, let's assume that the value of k is 1. Then we will have only one cluster, and this entire data set will be a part of this cluster. We will have to move this central points in such a way that its distance from all these data points are minimum, the squares of distance. So it will come out somewhere near here, somewhere near here. Now this is a very little, of course it will be a large value, but if we make this number of clusters as 2, we will have the luxury of 2 central points. So one can be somewhere near here and another can be somewhere near here, and the sum will be lesser than what we got in when the k was 1. So with k is equal to 2, sum of the squares of distance from the data points is reducing. Now we make k as 3, which is the original example. So maybe the first cluster centroid will be here, this will be here, and this will be here. Again, this is going and to a lower value than the value of k. When the value of k was 2, it's the value when the k is 3 is much lower than that. Likewise, we keep increasing k, 4, 5, 6. So if you notice 1, 2, 3, 4, 5, 6, 7, 8, 9 data points. So up to 9, if we make the value of k is equal to 9, the sum of the squares of distance will become 0. After that, if we increase the value of k further, there will be no further decrement because that value is already 0. But Does this mean that we need to have the value of k is equal to 9? The answer is no. Let's try to understand why. In this diagram, I'm trying to explain this. Here the value of k is 1. So that is called distortion, means the total sum of the squares of all data points when k is equal to 1 is very high value. Now with value of k is equal to 2, it has reduced substantially. With the k value of 3, it has further reduced. But suddenly you notice if the value becomes 4, the reduction is not that substantial. So the reduction is only this much. The reduction is value in only this much. It's only this much. Now it has become 5, then the reduction is again not very substantial. So that is the point at which the reduction in the sum of squares of distance suddenly starts deteriorating. It's not much significant. Means by adding additional cluster, we are not adding much value. That is the optimal value of k. So in this case, the optimal value of k is 3. So 3 is the optimal value of k. Because after 3, if we keep on increasing the number of clusters, the reduction in variation is not that significant. So that's the whole point. So the value of k will be 3. Of course, going to my earlier explanation, if we increase the value of k to the number of data points, of course the value of the variance will be 0, because each data point will then become a cluster which will not solve our purpose. Although the variance will be 0, some of the variance will be 0, but that's not what we are looking for. Yeah. So this is in brief about the two-dimensional data, how we do the calculate the value of k. Now going back to the original problem, this was the problem which we discussed. We took only two data columns here. Now if the column number is 3, we apply the same logic. Only thing is that the number of dimensions will be 3, and to calculate the radial distance, we will have to apply this formula x square, that is the x-axis distance, y square plus another variant will come, that is for z value, plus z square, and that will be the value of, so this will equal to the value of r square, that is the radial distance. If the number of column is 4, then x, y, z may be some other value, x, y, z, w whole square. So likewise we calculate the radial distance and we get the optimal number of k which can do the clustering of data and which can classify the data into optimal number of clusters. So hope guys you have understood what clustering is all about and how it works. Now coming to the other part, can we apply this clustering into a stock market? As I already tried to see how this clustering can be utilized to group the stocks, similar stocks together. Okay, here I have a data of around 934 stocks, and these columns represent their returns. This is the return generated by this stock, this company, in last stock price in last 1 day. This return was generated in last 1 week. This is 1 month return. This is last 3 month return. This is 1 year return, 3 years, 5 years, and subsequently 10 years. 10 years let's not consider because we have not taken, because many of the stocks were not listed 10 years back. So this we have not taken into our train model consideration. But anyway, for the sake of your information, I'm showing it here. So up to 5 years we have considered here. So now the challenge is to classify the stocks which are similar in nature. So we will use clustering, and with the help of that clustering we will be able to grade these stocks to various classes. Let's do it. So let me run this. This is not a trained model. I'm yet to save it as a trained model, but just for the sake of purpose of demonstrating you, I'm showing the result. The result will be similar. Okay, so this is the result we have got. And now let me download the results. So this is the result we have got. This is again is a list of all these 934 companies that we already discussed. Now these are the optimal distances. It has classified this into 4 clusters, which I already explained you. So these clusters name are 0, 1, 2, 3. These are the 4 clusters identified, and these are the distance of the centroid of these clusters. The data point from the centroid. This is what it has done. I already told you I have not considered 10 years of data, so only till 5 years data I have considered. Now to see how this cluster works. So it has classified these stocks into 4 grades. These are the first grade stock, second grade, third grade, and fourth grade. Doesn't mean that first grade is the best one or zero grade is the best one. 0, 1, 2, 3. So let's see which is the best one. So just it has classified into 4 clusters. Let's take 1 month return. Now if you take this 1 month return of the entire data set, okay, this is coming out to be 3.24%. This data is taken on 22nd November 2018. So from 22nd November 2018 till last 1 month, the entire 934 set of stocks, it gave this average return 3.24. Now we see how this clustering works. Let's take the zero data set. The stock which belong to the zero cluster. Their return is less than the average, 1.24. Now we take the cluster number 1. Here the total number of stocks is 174. The return has considerably increased. From 3.27 it has become 6. So these are somewhat better stocks. Now we take number 2. Now you see the mind-blowing result. This is 19 average. The average has become 19. Although the number of stocks has reduced here. It has taken only 37 such stocks. But the average return is now 19 here. Now we take the fourth cluster, 3. Again, this is slightly less than average. So this is below average. So what we are inferring that cluster number 2 is really good, looks like, if we take 1 month return. And 2 is really good, that is excellent, and 1 is somewhat good. Let's try this on 3 month data. This entire universe of the stock of 934 has given a minus 11% return in last 3 months. Okay. Now let's do the same, apply the same principle here as well of clustering. Let's see how much return the stocks from cluster 0 has given. So the number of stocks are very high in this, T27, and the return is now minus 11. So much below. Now we go to the cluster number 1 for 3 month data I have taken. This is now substantially reduced, so it's good. In previous 1 month return data also, the cluster 1 was performing really good. Now let's go to the cluster 2, which was the top performer for 1 month data. Here also it's the top performer. So again it's 23%. So the average becomes some negative, from a high negative value, it's become a high positive value. And again this third one, which was slightly below average, here also it is slightly below average. So the same thing we are getting. So what we can infer, that grade 2 stocks are the best ones, as perhaps the best one, because it's not that all the stocks from cluster 3 at 2 has given a handsome return. There are a couple of negative ones also, Dell Network -3, but on an average the returns are very high. Your odds are very high of getting high return in next 1 month if you are sticking to cluster 2. So this is one inference you can draw, and if you are a positional trader, you can definitely utilize this artificial intelligence technique for your trading purpose. Likewise, there are many other techniques which I already mentioned. You can visit our website and see how this artificial intelligence technique can be applied. But this is how you can apply artificial intelligence. One small application I have shown here, how you can apply clustering in a stock market. In coming videos, we will try to explore more on this aspect one by one. Thanks for watching.